Hello, friends. In the last video, we introduced the topic of regression and did a simple example of linear regression. But the question arises, how should we decide which regression technique should we use? Well, there are both a short and a long answer to this question. The short answer is just look at the data and you would find out. And the long answer is again look at the data, but this time also understand what kind of the behavior the data exhibit with respect to the independent variable. In this video, we are going to observe and give our opinions that what type of regression could be used after observing the available data. Let's take the first example. It is very straightforward to say the linear regression works well for the figure on the left, but it is certainly not true for the figure on the right. In this case, we see that the relationship between the variables seems to be nonlinear and can be approximated with a polynomial equation, so it is better to use the polynomial regression. In this image, the plot on the left is surely meant for linear regression and used here just for reference. But if we observe the behavior of dependent variable in the figure on the right, here we clearly see that the dependent variable is categorical, or in other words, binary or ordinal. In this case, we use the regression techniques called logistic regression. And the function that is shown with the red line is called sigmoid function and widely used in machine learning application. It's also suitable for predicting probabilities and classifying observations into different categories based on predictor variables. If the value of the dependent variable is dependent on time or duration that could be represented in second, minutes, hours, days, or even months. In that case, we represent the data as time series data. For example, in this plot, we show the monthly data of the temperature in the beautiful Yellowstone Park in Wyoming and the number of visitors visiting the park. Here we see the data is directly related to the day of the year. And finally, random forest regression, or random decision forest regression, is an ensemble learning method for classification, regression, and other tasks that operates by constructing multiple decision trees, as shown in the figure. Enable learning methods aim to make more accurate and robust decisions without overfitting. Finally, let's consider the following steps when choosing a regression technique. Understand your data. Identify the type of data you have, continuous, categorical, time series, etc., and examine its characteristics, such as distributions and relationships between variables. Define the problem. Clearly define the goal of your analysis and the specific questions you want to answer. Assumptions. Check if the regression technique you want to use satisfies the assumptions of your data. For example, linear regression assumes a linear relationship between variables and homoscedasticity, constant variance. Model complexity. Consider the complexity of the model you need. Simpler models are easier to interpret but may not capture complex relationships, while more complex models may be prone to overfitting. Performance metrics. Decide on the evaluation metrics that are most appropriate for your problem. For example, mean squared error, R-squared, accuracy, etc. Cross-validation. Utilize techniques like k-fold cross-validation to estimate the performance of your model and prevent overfitting. Try different models. Experiment with different regression techniques and compare their performance to select the one that best meets your criteria. Interpretability. Consider the interpretability of the model, especially if you need to understand the relationship between predictors and the outcome. Remember, there is no one-size-fits-all approach. The best regression technique depends on the specific characteristics of your data and the goals of your analysis. That's it for now. Thank you for watching and see you next time. Take care of yourself and others around you. Bye for now.